Alright, today we're getting a preview of how Punnett squares work. Punnett squares are how you can determine the chance of two parents with certain traits passing them on to their offspring. So in this case, the parents are the bears, the polar bear and the black bear on the outside. Parents are represented on the outside. And the four cute little cubs in the boxes are the possible offspring. Now this is not correct. Traits do not inherit this way. If you breed a black bear and a polar bear, you do not get a panda bear. Traits that we're going to look at, dominant and recessive traits, are far more simple. So, first up, some vocab. A gene is a set of instructions for a trait. So we would be looking at eye color specifically. And I'm just having too much fun making graphics. So a gene has instructions for eye color, but those genes might not always be the same. So we get two pairs of genes called alleles, one from mom and one from dad. And most genes have two forms of a trait. So in this case, we can have yellow or green eyes. That's what we're going to pretend with. So genes, a set of instructions for a trait, often exactly the same, but parents give us each their own set of instructions, and those alleles for that trait can code for something different. So the dominant trait is the trait that's always shown when one allele is present. So if you have one set of instructions for the dominant trait, you get the dominant trait. So there's two combinations. In this case, for yellow eyes, if both your instructions are for yellow eyes, obviously you get yellow eyes. If you have one instruction for each, yellow and green eyes, then you still get yellow eyes because it's dominant. That's what your body decides to do when it has conflicting instructions. With a dominant trait, it picks the dominant trait and ignores the recessive trait. The recessive trait can only be shown when the allele is alone, in this case with lowercase y's. Why are green eyes represented with lowercase y's? Because the letter we use is of the dominant trait. So whatever letter you're using gives you a major hint which trait is dominant. So yellow is dominant because we're using the letter Y. If green eyes were dominant, we'd be using the letter G. Phenotype. Phenotype is a fancy word to say what the organism looks like, or the trait that actually showed up and presented itself. So, a phenotype is yellow eyes or green eyes. There are only two phenotypes with a dominant and a recessive trait. There's only two possibilities. So if you have to guess, it's a 50-50 shot. Genotype is the pair of instructions received from parents, and there's three possible pairs. We can have both capitalized letters, meaning the dominant trait, in this case yellow eyes, one of each, which still looks like the dominant trait, but it's a different genotype, so capital Y, lowercase y, and both lowercase letters, which has to be the recessive trait. Dominant and recessive genotypes don't show up as a mixed trait in this case. You don't get greenish yellow eyes if you have one of each. You don't get one green eye and one yellow eye. That kind of thing, when it happens, is developmental, not hereditary. Something went funky in development to get different colored eyeballs. So while that can happen, especially with cats and dogs, that is not an inherited trait, but a developmental thing. So this is what happens. The dominant trait shows up when you have instructions for the dominant and the recessive. Next up, probability. This is the type of math that says the chance of something occurring. So there's many ways to show probability. We can show fractions. So a fraction of a half or 3/4 would be a good answer. We can show ratios. A 1-to-1 ratio is the same as a half, or a 3-to-1 ratio is the same as 3/4. And we can show percentages. So 50% is the same as a half or a 1-to-1 ratio, and 75% is the same as a 3-to-1 ratio or 3/4. These are all based on quarters because our first set of Punnett square has 4 boxes, and so the outcomes are pretty simple. It can only be 0%, 25%, 50%, 75%, or 100%. the same as 0 quarters, 1 quarters, 2 quarters, 3 quarters, or 4 quarters. Now, we abbreviate the gender of the parents with 2 symbols. Now, this isn't always necessary. You don't always need to know the parent's gender, but sometimes you do. And so mom gets the little plus sign, a circle with a plus sign, and dad gets a circle with an arrow. Now, the arrow normally is pointing off and up to the side, but it went funky on me here. All right. Now we have our scenario. A female yellow-eyed cat breeds with a male yellow-eyed cat. What do we do? So to figure this out, mom up top has a capital Y and a lowercase y, and dad has only capital Y's. Why the boxes are split is because parents only give one of their instructions, one of their alleles to their kids. So mom could give her capital Y or her lowercase y. We just fill those down. Dad could give his capital Y or his other capital Y. Dad's kind of boring here. And what we get is what percent of the offsprings would have yellow eyes? Well, what percent of those boxes have at least one capital Y instead of instructions? All 4 boxes. So even though the boxes aren't the same, all 4 out of 4, or 100% of the kids would have yellow eyes. What genotypes are possible in the offspring? Or the kids, the boxes represent the kids. There's 2 genotypes. Half, or 2 quarters, or 1/2 would be capital Y, and 1/2 would be lowercase y, capital Y, or capital Y, lowercase y. It doesn't matter which way you say it. If they have one of each, it's the same thing. Now, true breeding, as defined in the book, was kind of a messy definition, and it talked just about plants. The definition is simpler than that, so we're going to get rid of that. We're going to have a simpler definition. A true breeding organism will always produce offspring with the same traits as themselves. So was this couple true breeding? All their kids had yellow eyes. They had yellow eyes, but the answer is no. Even though they had 100% kids with yellow eyes, half the time their kids would be hiding instructions. That's what we call it when their recessive instruction is hiding, when it's there but not being shown. So mom was hiding the instructions for green eyes. Half the kids will also be hiding the instructions for green eyes. So dad could be true breeding with a different partner, but mom cannot. So in this Punnett square, what was wrong with this? You don't get a third phenotype. So we deny this one. That's not correct. When you have dominant and recessive genes, it can only look like 2 things. So your 2 parents with different traits can't mate and get a third brand new trait. Not with dominant and recessive genes. In Chapter 6, we'll learn about some other more tricky ways that could happen. So I have a video. We're not going to play that video right now. And you can check it out for examples of how to do tomorrow's work. So that's a red cat, blue cat example. In this case, red is dominant because we're using the letter R. And that video will take you through several problems. So, which cats will you get tomorrow when I upload the assignment? We'll see. When you do the Google form to practice your Punnett squares, after you're done, check your responses, and you can and should edit your responses until you get a perfect score. I'm trying to make this as easy as possible. I've decided we're not testing Chapter 5. We're just going to practice Punnett squares really hard. So this is our introduction to Punnett squares. Good luck, and my Zoom today is from 11 to 11:30.